Hello, my dear friends. Chapter number 13, topic number 2, relation between electricity and magnetism, standard 10th, and subject is that of the science. Now, this person, Hans Christian Ørsted, a very famous name in the field of electricity and magnetism, in 1820, see, almost more than 200 years back, he observed accidentally
Wow.
that whenever current is passing in a conductor, a magnetic needle used to deflect. He thought in his mind, there isn't any connection between this electric current and magnetic needle, compass. Compass always used to point towards the north. You should remember this. You might be knowing this. But why this magnetic needle starts deflecting? Why does it deflect from the north direction whenever I used to pass current through it? So he astonished. He was amazing. Why is this? And Ruth also used to amaze. Wow, what's this? This is something different. This is a bizarre event. He passed a current through circuit. He just turned on the switch. And whenever he turned on, every time he observed that the needle used to deflect. He made little change. Now what did he do? He simply changed the battery. He simply changed the connection of the battery. Now what did he observe? When he changed the connection of the battery, the current starts in the reverse direction. See, this is the forward direction in which when current starts to flow, the needle used to deflect in this direction. But when he started the current in the reverse direction, when he changed the polarity of the battery, what did he observe? He observed that when needle was deflecting in this direction, now needle has started to deflect in opposite direction. That means needle's deflection is 100% dependent on the direction of the current. Observation number 1. What did Ørsted observe? He observed that there is a deflection in the magnetic needle whenever there is a current passing through a conductor near it. Observation number 2. Whenever we change the direction of the current, then the deflection direction also changes. And observation number 3, that whenever we keep away, whenever we start dragging the magnetic needle away from the current carrying conductor, the deflection used to decrease. So these were the 3 observations that were made by Ørsted in 1820, and he concluded that the very simple magnetism, just like this Gita and Sita, the picture of Hema Malini which you might have seen or at least your grandpa might have seen. You may ask this question to your grandpa, दादाजी ये गीता और सीता कौन थी? हेमा मालिनी का पिक्चर था गीता और सीता. There was Hema Malini who did the role of Gita as well as Sita. So we may say Gita, who was very naughty and very active girl, and Sita, he was very simple in the nature. So Ørsted observed that magnetism is just like Sita, very simple girl. But that simple girl is affected with the X of Gita. Right? That simple girl Sita, that is magnetism, gets affected with the naughtiness of Gita, that is electricity. So he concluded that magnetism has some sort of effect. Magnetism is affected by electricity. This was his conclusion in 1820. And what were his 3 conclusions? I have already told you. Now let us discuss the properties of the magnetism. It is very clear, you already studied in the standard 8th and 7th, that whenever we just hang the magnet, it always tries, when we hang the bar magnet, it always tries to align itself towards the north-south pole. And you should be very much clear in your mind that Earth's north pole is basically magnetically south pole. The person who is willing to go in IITs, they should have a very clear mindset in their mind that north pole of Earth is basically south pole of magnetic pole of Earth, right? Actually, the magnetic pole direction is opposite to that of the Earth's north pole, right? So whenever we align a bar magnet freely hang a bar magnet with the help of the thread, that when we observe that it always tries to align towards the magnetic north and south pole. So north pole of a bar magnet always tries to align towards the magnetic south pole of the earth. And we may say magnetic south pole of a bar magnet always tries to align towards the magnetic north pole of earth. Or in simple words, we may say north pole of the magnet tries to align towards the north direction of the earth, and magnetic south pole of the bar magnet tries to align towards the south pole of the earth, right? So but remember, north and south are opposite in case of the earth's magnetism. Now second property of magnetism is that like poles repel and unlike poles attract. So N and N, when we try to bring them together, it will try to make them apart. They will try to repel each other. But when we try to make connection between north and south, they will try to attract each other. So like pole always repel, north north repel, south south repel, but north south or south north will always try to attract each other. They will attract each other. So these are the two main properties of magnets. Now let us try to understand about the magnetic lines of force. We have already discussed whatsoever background was needed, right? So already in standard 7th and 8th we have discussed that magnetic lines of force are nothing but the imaginary lines in which the small Paris powder used to align. If we just simply vibrate or tap the paper on which this powder has been sprinkled, what do we observe? We do observe that these lines, there are lines which originates from the north and which terminates at the south. When we draw these lines, it is very clear that lines used to originate from the north pole of the bar magnet and they terminate at the south pole of the bar magnet, right? And to summarize, we may say they are continuous loop. What are the properties of magnetic lines of force? They are continuous loop. This starts from the north pole and enters at the south pole. They do not cross each other. They never cross each other. You will have to mark up this in your mind that magnetic lines of force never used to cross each other. Field strength, that is the magnetic field strength, is proportional to the line density. What does it mean? Means greater the number of lines, greater the magnetic field, greater the magnetic strength. Field strength is proportional to distance, means greater the distance of an object from the magnet, lesser will be the magnetic effect. Smaller the distance, higher the magnetic field intensity. They have magnitude as well as direction. We had also seen these things in the Oersted experiment of 3 observations, right? So they have magnitude as well as direction. Magnetic field is stronger near poles, and inside a magnet, direction is from south to north. The person who eyes towards the IIT, they should understand that the direction of magnetic lines of force is always from north to south, but we say that they terminate at south pole, but that's not actually true. Actually, they enter to south pole and again comes out at the north pole. So the direction of magnetic lines of force inside the magnet is from south to north. Repeat, the direction of magnetic lines of force is from north to south out of the magnet, but inside the magnet it is from south to north. This concept should be very clear to my students. And this gentleman, who might not be knowing this gentleman, we had already discussed about this gentleman. He had worked in the book binding store and he used to read a lot those books. And then after wandering for the 17 years, keeping magnet in his pocket, he invented the laws of electromagnetism. He invented the generator. Who is this? He is none other than Michael Faraday, a father of electricity. What did he observe? He observed that whenever we are bringing a magnet towards a coil, then he observed that a light blinks. A light appears in the lamp. Means some sort of current is flowing. current starts increasing, then it decreases. Whenever he brings the magnet with speed, there was jerk of electricity in the line. But whenever he was dragging out that magnet from the current from away from this coil, then he observed that again there was a jerk of electricity and there was a light in the lamp. So he put a meter instead of lamp, and what did he see? That whenever he just pulled the magnet towards the coil, then the direction of the current which was generated was like this. But when he tried to pull out, when he tried to drag away the magnet from the circuit, then he observed that the direction of current generated is now reversed. Means, observation number 1, change in magnetism produces electricity. That was his very first observation. Whenever we change magnetism, electricity is generated. Observation number 2, when we keep the magnet stationary, coil is stationary, magnet is stationary, no generation of electricity produced, no generation used to produce, no generation was there. Means, observation number 2, there is a requirement of change in field always. Greater the speed, greater amount of electricity will be produced, right? So he made certain conclusion that whenever a stationary object is there, no generation of electricity used to take place. Whenever we bring in, direction of current is something different. Whenever we bring out, direction used to change. So these were his conclusion. Conclusion number 1, whenever there is a change of magnetic field, there used to be electricity generation. Conclusion number 2, no current will be produced if magnetism and coil are stationary. Conclusion number 3, direction of the current depends upon the direction of magnetic lines of force, right? So these are his few conclusions from this. And now this device which used to detect the direction of the current is known as galvanometer. Now, after this observation, Faraday made certain conclusion just opposite to that of the Oersted, that there is also relationship between Gita and Sita as well as Sita and Gita. What did he say? Oersted say that Sita is having certain relationship with Gita, but Faraday say Gita is also having certain relationship with Sita. Means Sita and Gita, they are not different, but Sita and Gita, that is magnetism and electricity, they are nothing but just two different forms of Hema Malini. Means Sita and Gita, they are not Sita and Gita, only names are there. They are simply twins, but they are nothing different but same. And what is that same thing? Same thing is that was said by Oersted as well as the Michael Faraday. And what is the conclusion? Conclusion that electricity is nothing but the magnetism and magnetism nothing but the electricity. Means electricity and magnetism, they are twin sisters. Electricity and magnetism are nothing but simply two forms of energy. And we may say when electricity and magnetism combines, then there is a common word we found, that is electromagnetism, right? So electricity and magnetism, they are interconnected with each other, and combinedly they are known as electromagnetism. Thank you for watching. Thank you.